Hello again. Okay, what we're going to do now is we're going to learn another differentiation rule. And up until this point, we've looked at more or less, how many rules do I have here? It looks like one, two, three. And this is a fourth one. There's really two rules wrapped up into here, I guess. So four rules are pretty basic. The most powerful one so far has been our power rule. You're going to learn that's going to be your friend. The power rule is a very nice rule when calculating derivatives. We also learned, well, at least one of them for sure. The other one I'm just telling you right now. We looked at a very specific derivatives. These aren't really rules. These are just derivatives. And we saw in a previous video that the derivative of sine, amazingly enough, is cosine. And for anybody who doesn't think that's cool, well, I don't know that you truly understand what a derivative is. I think that's a really cool thing that the cosine curve describes the slope of a tangent line to the sine curve at any point x. That is just a really cool thing. We derive that using the limit process, our f of x plus h minus f of x over h, and we took the limit as h went to 0. We didn't do that for cosine, but we could, and if we did, we would get negative sine describing the slope of any tangent line to the cosine curve. Again, a pretty amazing thing. Okay, well, in this video, we're going to look at a new rule that we call the product rule. And I'm not going to prove it, at least in this video. If enough people need to see a proof, I can do that. But I'll just go ahead and give it to you, and then we'll do some examples. Okay, so what is the product rule? The product rule is, if I want to find the derivative of a function that's defined as the product of two separate functions, the product rule says to take the derivative of your first function and multiply it by your second function. And then you're going to add to it the derivative of your second function times your first function. Whoops. I'm going to stay consistent here. There we go. Sorry. Okay, so there's your product rule. Now, at the risk of this just becoming a mechanical exercise where I give you a function and you kind of spit back the derivative, that's easy enough to do. I don't want you to lose sight as to what it is we're actually finding. So let's make up an example here. Let's say that we have the function, we'll start off easy, x squared times 3x cubed plus 1. This is a really easy one. In fact, I probably wouldn't even use the product rule in this case, but I'm going to use the product rule just to demonstrate how to use it. Okay, so what are we really doing when I say find the derivative of f? What is it that we're actually finding? Well, let's pretend for a moment. Let's pretend for a moment that this, let's say that this curve right here looks something like this. I don't know what it looks like. I'm making this up. If you have a calculator, okay, you can graph it and probably see that it doesn't look anything like this. In fact, it doesn't. I can see that right away. But anyway, let's just say that it does. Okay, so if I want to find, if this green curve represents f here, what does the derivative represent? Well, the derivative represents really the slope of any tangent line at a point x. So let's say we wanted to find the slope of the curve right here. Maybe this is 5. Okay? I want to know, what is the slope of this green curve at 5? Well, if we go up to 5, you'll see that it's pretty flat up here. It kind of comes up here. It's really steep right here. It flattens off, and then it gets steep again. Okay, so this tangent line then, this tangent line represents, well, at least the slope of the tangent line represents the derivative of this function at 5. So we could say f prime of 5 equals 0. Okay, another way to say it would be the change in y, dy over dx, the change in x. This is just slope. Isn't that what slope is? A change in the vertical over the change in the horizontal equals 0. Okay, maybe over here, what if I wanted to find the derivative over here at -3? Well, what's the slope of that curve at -3? Well, the tangent line to that curve might look something like this. Okay, and I don't know, what does that look like to you? Looks probably maybe 2. Maybe it has a slope of 2. So we would say f prime of -3 equals 2. Okay, so this is really what we're doing here. We're finding slopes of tangent lines to functions, and it turns out those slopes have an incredible amount of meaning, as we'll see in some future application problems. So how do we do this? Well, we have two functions here, and if I were to do this, if somebody gave me this problem, I would probably just distribute this x squared and calculate the derivative how I normally do, using sum and difference rule probably, but let's use the product rule. Well, the derivative of x squared is just 2x. And then my product rule says to multiply by my second function. Okay, so the first part is done. Now the second part says take the derivative of your second function, which is what? What is the derivative of 3x cubed plus 1? Well, the derivative of 3x cubed is 9x squared, and the derivative of 1 is just 0. That's our constant rule. Okay, times what? Times our first function, which is just x squared. Okay, so really you're done. The only thing left to do, I suppose, would be to distribute this through and maybe combine some like terms, but I'll let you do that. I don't think we need to take the time to do that right here. Okay, so let's look at another function. Let's say we have a function, the sine of x times 3x squared minus x. Okay, so again, we have a product of two functions. This function right here is behaving like my h of x, and this function right here is behaving like my g of x. Okay, so let's go ahead and find the derivative of sine. What is the derivative of sine? Well, we know that. We know that from a previous problem. We don't have to calculate it with our limit process anymore. It's cosine multiplied by 3x squared minus x. Remember that I don't take the derivative of g just yet. Plus, I suppose I should write f prime over here. Okay, plus what? Plus the derivative of my second function. And that will be, what's the derivative of 3x squared minus x? Well, it's 6x to the first power minus the derivative of negative x is 1. And I'm going to put some parentheses around this, because when I multiply it by my second function, I want to make sure that I multiply the entire derivative by the second function. And there you have it. I don't really know how to simplify this much further beyond what it is. There's no reason to. That is your derivative. Okay, so again, this is just another technique that we can now add to the host of rules that we're kind of building. And once we build these rules, we're going to look at a couple more here in the next couple of videos, but once we're done building all the mechanics of it, then we can look at some more complicated problems, some application problems, and you can see the real power of the derivative. So I will see you around, and I hope that made sense to you. Goodbye.